Hello, everyone. Welcome back to SAT Math Question of the Day with Professor Emeritus Seth Chaiken at University of Albany and Joel Chaiken, his brother. Hey, Seth.
Hi.
Hey, how
Hi
you doing?
again.
Okay, hi.
Hey.
So you never know what you're going to get here, but you know you're going to get some. We're going to try to help you approach SAT math questions. We actually did this question yesterday, but in the middle of the video, if you watched it, I don't know if you noticed, but I said, Seth, is there a brilliant way to do this? Is there a way that like a genius would figure this out without having to do it the normal way? And Seth said, I don't know. Anyway, he thought about it. Kudos to Seth, and he came up with one. I can't wait to know. I can't wait to see what it is because actually I don't know what it is. So before Seth shows us the way to do it without doing it the traditional way, I'm just going to quickly show you the traditional way. Okay. So if you do it the traditional way, if you knew b, then you can calculate f of negative 2, which means the function evaluated negative 2, but you don't know b. So use this as a clue to get to solve for b, and then you know b, and then you get the answer. So very, very quickly, you do 7 is equal to 3 over 2, 6x plus b. These cancel. 7 equals 9 plus b. You can see that b equals negative 2. And then f of negative 2 then is 3 over 2 times negative 2 minus 2. These cancel. You get a negative 1. Negative 3 minus 2 is negative 5, and that's the answer. If you wanted this to be done slower, watch yesterday's video. Seth, now I'm dying to know. Now, do you want me to erase what I wrote, or
No, leave it.
Okay,
So
great.
people
Okay.
could see it again. Could compare.
Yeah.
Okay. I called the method we did yesterday the follow your nose method.
Mm-hmm.
You simply, take the information that they give you in the order that they give it to you. You figure out whatever you can from what's already given or figured out, and you just take one step at a time, like a journey, and you end up with the goal.
Got it.
Okay, so method 2.
Ooh, I think I see it.
Okay, second method.
So
it's not quite a genius. You don't need to be a genius to know this. You just need to observe and recognize that you could use a basic fact about the situation.
Okay.
So here we go.
Now, if it's not the same thing I'm thinking of, then I have a third way of doing it.
The situation is we're given a so-called linear function. Mathematicians actually call an affine function of the form 3/2 f of x equals 3/2 of x plus a constant. Well, if you were to plot this function, it would look like this, right? I'm not drawing the axes. The 3/2 tells you that the slope of the curve is 3/2. Right? Okay. Now, they tell you the value of the function at x equals 6.
Right.
And they tell you that now I will draw a y-axis somewhere. That at x equals 6, y equals 7. Right? Now, they're asking for what the function value is at negative 2. Well, negative 2, is a bit to the left of negative 6. Minus 2. X equals minus 2. And we would like to find question mark. And so what's the situation? We know the slope is 3/2. So let's draw the triangle that manifests the slope. And what this is telling you is something about how the value y, when y equals f of x, how y changes when x changes. Well, how is x changed? It got changed from an old value of 6 to a new value of -2. So how much is the change?
8.
The change is
It's 8.
well, it's 8. Is it 8? No. The change in X is, when we talk about changes in math, we take the new value minus the old value. So the new value is -2. We compare the new value
-8
with the old value. And so the change in X is -8.
Right.
Okay. And now, since we know the slope, that will, using the slope, so the corresponding change in Y equals the slope, which is 3/2, times a change in X, which is -8. And we see that is 3/2 of 8 is 12, but it's negative. So the change in Y, let's see, is the new minus the old. That change is -12. Okay. And then we're interested in not what the change is, but we're interested in the result of the change. The result of the change is result of -12 change in Y is the old value of Y, which is 7 plus -12, and that is -5.
Wow. Yeah. Soon after you said, I have another way of doing it, and you said that, I looked at it and I said, oh my God, you could just use the slope.
That's right.
Yeah. So can I just have...
So this avoids the intermediate step of explicitly finding B.
Right. Yeah, that's a really good way to do it. And it also really emphasizes the importance of slope. Yeah.
So it emphasizes the meaning and application of slope, and it entails the fact that, when you have a function like this, the constant B and the slope are independent.
Right. Yeah.
And that a problem involving the slope, this is a problem that can be solved by working with the slope alone. And so you could merely use the B to tell you that the function in question, has a constant slope.
Yeah.
And really don't care. We don't care what the value of B is.
Right. Yeah, that's why yesterday I had this gut feeling. This smelled like an SAT question where you didn't have to use what I would call brute force, the normal way. Seth said, follow your nose. Just had this gut feeling that's this classic SAT where they would give this to you and there's a allegedly faster way. I don't know if it's really faster. So Seth, may I make a few comments on your solution?
Yeah.
Okay, first of all, this whole thing about all the negative signs and all this caring about the directions, it's really unnecessary. It's really
no. It's really I couldn't be able to do it without it because you can get really confused.
No, it's more confusing to have all these negative signs. Graphically, you know the difference. If you graph this, and this is an honest graph, set graph. If you know this, then you know the distance here is 8. And then you can figure out this distance, which we could talk about in a second, is 12. And then looking at the graph, you know it's 7 minus 12. You don't have to be so concerned about all these signs.
Okay. Well, yeah, again, there are multiple ways of approaching it.
I know.
Multiple ways of approaching it. Different people think of it differently.
Right.
If you want to think in terms of algebra, it's really important to know that change is new minus old.
That's true.
If you think of it geometrically, then you must draw an honest graph so you can see what the directions are, and then you apply what Joel said.
Right.
The base of the triangle has length 8. And therefore, the altitude of the triangle has length 3/2 of 8, which is 12.
Right.
And then to get the new y value, you need to go down from the old y value. So there are two ways. I don't know. It's a good idea. Please, think over both of them.
More intuitive. Okay. So Seth, I'm misspelling intuitive probably. Seth did it rigorously. Seth majored in physics. Directions matter in physics. Seth did this very, very rigorously, right? He's totally correct. The chain is okay. I did it more intuitively because I just looked at it and knew that you had to go down. And this way you don't get so hung up with all these negative signs, which frankly you don't really have time for on the SAT to do it rigorously. If you can get away with doing it more intuitively, then you should do it more intuitively. And Seth did this little thing here. He just said, 3/2 times -8. That was done a little fast. You can see also that these are similar triangles. You could do it that way. This is 3/2. You could do similar triangles, right? 8/2 is equal to 3/x.
Yeah.
Right? Or you can know that the slope is the change in the y. The slope is change in y over change in x. And you know the change in x is 8, right? And this is 3/2. So then this is 12. You could cross multiply and get that. Okay, so there are different ways to see this. Seth did it. Seth just wrote it out like he knew what he was doing. He did know what he was doing.
So the change, the magnitude of the change is 12. You start with 7. Okay, they didn't give you a distractor where you made a mistake by adding positive 12 to 7.
Right. Oh, right, yes.
Yeah, they might have given you a distractor of 19.
Oh, so in other words, but they must have known when they designed this question that people could do it both ways. They must have. They must have.
So let's see. We solved for the method we showed yesterday was to solve for B, and the value of B, right, is the second distractor.
Right. Yes.
Choice B.
Yes. So they were really probably 80% of the people who do this question are going to do it this way.
Well, I don't know. We can't make guesses like that without some data.
Of course we could, but we could be wrong. We can make a guess. We may not be right, but we can certainly make a guess.
It's a wild guess as opposed to an informed guess.
Okay, fine. Yeah, see, Seth's being rigorous. So that's really good. That was really great that you used slope. That was fantastic. I hope I didn't go a little bit too fast with this. Change in y over change of x is 3/2. That's the slope. The change in x is 8. We don't care about signs because we're doing this intuitively. So
we're doing it geographically.
So you see 2x is 24, x is 12. You know this is a positive number, but it's not really, it doesn't mean up. It means that it's a 12 change, okay? These are just changes, and then you look at the graph and you know it's 12 down. Plus, you're right, they didn't give you 12 up. So you can't even make that mistake, right? So and again, this is they're giving you extra information you don't actually need to be. Wow. Yeah.
So it leads me to think that they didn't think that people would apply my method
right
in the algebraic way
right
without the intuition.
Well, that's why I said there was an 80. That's why 80% of the people doing this probably are doing
Who
it
knows?
this way.
Well,
Because
maybe the SAT makers
yeah,
made the question on the assumption that a lot of people would do it the way we did first, which is
right.
solve for B.
But which way do you think
And
is
that,
faster?
and that the distractor would be, people would, once they solve for B, they think, hey, I solved the problem.
Right,
And
right,
pick the value and not answer the question.
Yeah.
Which is a mistake I actually made in one of these episodes, remember?
Yes. Yeah.
Okay.
Then I'm just last little question about this is which one do you think is faster? I don't know. I don't know which one is faster. This one takes less mental energy. This is less mental energy, which is important because you're taking the SAT. It's a performance sport. You need perseverance. You don't want to use up your mental energy. But I don't know. Maybe this is pretty fast.
Yeah. No, I think the first way is slower.
Yeah. Okay.
And requires more mental energy because you really do have to be careful with the signs.
Yeah.
Whereas if you use Joel's geometric intuition,
yeah,
you could merely do the calculations.
Yeah. So I have one more thought about this. This is an interesting thing. I just realized. Let's play with this problem. Let's do it. Okay, the problem with the way this is done, the problem with the way Seth did it, is that you could easily mess up the 3 and the 2 and the 2 and the 3. It's easy to mess with slope. It's easy to do x over y, y over x. You get confused. 2 over 3, 3 over 2. Let's solve the problem.
I was clued by realizing that the slope was greater than 1. So it was a very slopey line.
Okay.
And so that led me to make sure that the rise was larger than the run.
I know, but let's
sometimes the change in x is called the run, how much you run, and then the change in y is called the rise,
right? So
how much you go up.
So I know
after running the run.
But this is my point. Let me make my point more clear. Let's do the problem wrong and see if it's one of the distractors. Because if they think people are doing slope, they have to therefore assume someone's going to do it wrong. Someone's going to go 2 over 3.
Well, then you wouldn't get an integer solution.
So you see, that means that they weren't expecting people to do slope.
Because
if they were, they would have put this in as a distractor. So it says integer. I will let me prove it to myself. 16 is equal to 3x. Oh my God.
2/3. 2/3 of 8. Is 2/3 of 8. 8 is not divisible by 3.
So this is clear example. I mean, not clear. It's obnoxious to say. I don't want to do that. This suggests that they really didn't expect people to do it this way. Because if they did, they would have made this a distractor answer.
Yeah.
Because everybody messes up slope. It's too easy to mess up slope. So that means they really didn't expect people to use the slope. Right?
Right.
Because they would have put that as a distractor. Wow, we're really analyzing this.
Well, maybe the distractor of 7. The distractor of 7 is to catch people who have no idea what functions mean.
Oh, you mean 3? Oh, yeah, I always forgot to be
F is 7. 16. Yeah, F is 7. Yeah,
doesn't it look like 16 is divisible by 3? 16 looks like it's divisible by 3, but it's not. So this is what? This is 5 1/3.
No. So I'm talking about distractor D.
Yeah. No,
the data.
Distract is the.
Just how did they come up with distractor D?
I don't know, but I have a thought. My main sideboard get another color. I have a thought. It's equal to 7. Maybe someone, not a math person.
Yeah. F is 7. No, that's wrong. F is a function. It is not a number.
I know. But if people don't know the notation, they
don't know.
That's why it's there.
Yeah.
Okay, and why we seriously killed this problem. I mean, this problem is completely slaughtered. Okay, everyone. Hope you enjoyed our little discussion here. I hope you got something out of it, not just enjoyed it. Oh, what is going on? Oh, Microsoft did it again. Some silly whiteboard just came up on my screen. Everybody saw that. Okay. Okay, everyone. Then have a great day. And I guess we're done, right? And like us, dislike us, give us comments, and of course, email us at SAT Math Question Update. But we don't check the email that often, so just be patient. Okay, everyone. Because we're too busy doing this stuff rather than checking our emails. Okay, everyone. Take care. Bye.